All right, let's get into it. Today we're looking at a paper that's arguing for a pretty huge shift in how we think about building AI systems. Basically, moving them from this world of unpredictable magic into the realm of reliable, predictable engineering.
So let's kick things off with a story that honestly is pretty wild. A car dealership's AI chatbot recently went a little rogue and agreed to sell a customer a brand new car for just $1. Yeah, $1. So, was this just some simple coding bug? Or is it a sign of a much deeper problem with how we're building AI right now? Let's dig in. First up, the AI dilemma. We're going to start by looking at why these kinds of spectacular, almost funny AI failures keep happening.
And it's not just that one chatbot. I mean, the problem is everywhere. You've got an Air Canada bot literally inventing a refund policy that the airline actually had to honor. Or what about the lawyer who used ChatGPT and it just made up completely fake legal cases? The core issue here, the thing that connects all of these, is that we're giving these super powerful tools really fuzzy, ambiguous instructions and then just crossing our fingers.
So how do we fix this? Well, to find the solution, we're going to take a page from one of the most reliable engineering fields on the planet, car manufacturing.
Okay, so think about it like this. On one side, you've got AI, and for a lot of us, it feels like this mysterious black box, right? You put a prompt in, something cool comes out, but you don't really know how or why. Then, on the other side, you have a car. I mean, it's an incredibly complex machine, but it's built from thousands of individual parts that are all perfectly understood and totally interchangeable.
So why do we trust a car? I mean, why do you trust that when you hit the brakes, it's going to stop? It's because every single piece of that car, from the engine block all the way down to one tiny bolt, has a super precise, unambiguous description of what it's supposed to do and exactly how it fits in with everything else. And that right there is the key. In the world of engineering, that precise description has a name. It's called a specification. And the argument here is that this is the missing piece of the puzzle for building AI that we can actually rely on.
Okay, so let's really unpack this idea of specifications. What does this actually look like when we apply it to something like a large language model?
So, a specification, at its heart, is just a rule book. Its whole job is to get rid of ambiguity. It tells a system component exactly what it's supposed to do. It defines the inputs, the outputs, and the expected behavior. No guesswork allowed.
And this is where it gets really interesting, because there are two crucial types of specifications we need to understand. First, you have the statement specification. This is the what. It defines the goal. Think of it like a product requirements document. Then you have the solution specification. This is the how. It's how you can actually check if the goal was met. This is like your set of unit tests in programming. So one tells you what to build, the other tells you how to prove you built it right. And if you look at this graph, the whole point of this entire methodology becomes crystal clear. We want to move AI development out of that bottom left corner, the ambiguous let's just see what happens zone, and all the way up into that top right corner, where our tasks are clearly defined and the results are totally verifiable.
Okay, so what's the payoff? Why go to all this trouble? Well, when you start applying specifications rigorously, you unlock what the paper calls 5 engineering superpowers.
And these 5 things, verifiability, debuggability, modularity, reusability, and automated decision-making, these are what turn AI from a creative craft into a predictable, reliable engineering discipline.
So let's break these down. Verifiability and debuggability are the absolute foundation. First, can we even check if the thing works? That's verifiability. And second, when it inevitably breaks, can we figure out why and fix it? That's debuggability. You need both to build anything you can actually trust.
Now this is where things start to get really powerful. Modularity and reusability are what let us build incredibly complex systems without starting from scratch every single time. It's literally like building with Lego bricks. You take smaller, proven, specified components and you snap them together to create something much bigger and more capable. And all of this leads to the ultimate prize, automated decision-making. We're talking about the ability to build systems that need exactly 0 human babysitting. Why? Because their behavior is so well defined, so specified, that we can prove they're reliable before we even turn them on.
All right, let's pull back and look at the big picture here. What is the main takeaway from all this research?
The central argument here is really a call to action. For AI to take its next big leap forward, it has to evolve. It has to stop being an art where we rely on intuition and happy accidents and become a true engineering discipline, like building a skyscraper or a bridge.
And what's so powerful is that we have seen this exact story play out before. Think about it. In the early 1900s, cars were built by hand, one at a time. Then came standardized parts and the assembly line, and the industry exploded. Same with computers. The first ones were these giant, one-of-a-kind machines. But then came modular, standardized components, and suddenly everyone could have a PC. Right now, AI is in that bespoke, monolithic phase. The future, according to this paper, isn't just about a few giant labs building bigger and bigger models. It's about an entire ecosystem of builders creating amazing things out of reliable, specified, modular components.
So, did this deep dive make your brain vibrate a little? Good. Excellent.
If it did, then you should absolutely subscribe to VibeDoc. Seriously, we're here to make sure you're never speechless when it comes to AI. We'll make you smarter and maybe a little more entertaining at your next dinner party, we promise. Come on, the button's right there.
And that really leaves us with one final big question. Following this engineering path is how we make AI reliable, for sure. But will we ever get to a point where we trust an AI as much as we trust the brakes in our own car? That's a question for all of us to think about. Thanks so much for watching.